This video is about simplifying rational expressions with like denominators. Notice that we are talking about rational expressions, which means we're going to be talking about expressions that involve a variable in the denominator. So that's it's filed under the slide as a new concept, but it's not new. We've seen rational expressions before. They're anything that has a variable in the denominator. Remember that that also means that all values that would make the denominator equal 0 are excluded values. So the first examples we're going to talk about are how to identify those excluded values. This is not a new concept. We've identified excluded values before. Remember when we had problems like this, and we've said that C cannot equal 0, because if C equals 0, then we're dividing by 0, and that's not possible. So we're going to do the same thing with these examples. Now, our examples here, we want to identify our excluded values. Our first example is 3 over 5m, and we want to know what would it take for that m to be to make our denominator 0. Now to figure that out, we're going to have to set our denominator, which is 5m, equal to 0, and then solve for m. Whatever value of m gets us 0 is going to be our excluded value. So to solve this equation, I divide both sides by 5. Those cancel. On the left side, I'm left with m, and 0 divided by 5 is 0. Now this tells me that if I plug 0 in for m, then my denominator will be 0. 5 times 0 is 0. So m cannot equal 0. That would be my excluded value. For this bottom example, 5m over m plus 1, I need to know what could I plug in for m that would make my denominator 0. So to figure that out, I'll take my denominator, m plus 1, and set it equal to 0, and then solve my equation. Now, m plus 1 equals 0. To get rid of the 1, I need to subtract it from both sides. And I've got m, these cancel, equals 0 minus 1, which is negative 1. So negative 1 is my excluded value. I can say m equals negative 1 is my excluded value, or I can say m cannot equal negative 1. And again, that's because if I plug negative 1 in here, negative 1 plus 1 equals 0, and that would make my denominator 0, which is not allowed. Now we're going to do some simplifying rational expressions. This is stuff that we have done before, and we simplify our rational expressions with a single denominator by factoring. So I'm going to factor the top, factor the bottom, and then see what cancels out. Now I've got 8h squared over 12h. So if I write this out in prime factorization, I've got 2 times 2 times 2, there's my 8, and then h squared is h times h. When I divide that by 12h, and I rewrite 12h in prime factorization form, I have 2 times 2 times 3 times h. So all I've done here is I factored the numerator, factored the denominator, and now I'm going to cancel out anything that's the same on top and on bottom. So I've got a set of 2's right there that cancel, set of 2's right there that cancel, and then a set of h's. Now what I'm left with is my simplified rational expression. So I've got 2h over 3. When I do that, I also need to identify any excluded values. So I need to know what could I plug in for h that would make my denominator 0. Since there are no h's in my denominator, there are no excluded values. So that is my solution. For this next example, 2m minus 6 over m minus 3, I don't have a single term as my numerator or my denominator. I have a polynomial as my numerator and denominator. So I'm going to have to, factor out the top and bottom, but I'm going to have to factor out the greatest common factor. So the first thing I'm going to factor is this 2m minus 6. Now I want to factor out this expression, and I have to do that by writing the prime factorization. So to get 2m, I multiply 2 times m, then I do my minus, and to get 6, I multiply 2 times 3. Now, what I have in common is my greatest common factor, 2, and what I'm left with is what goes in my parentheses, m minus 3. So these are the factors of my numerator, my 2m minus 6. Now in the denominator I have m minus 3. I don't know what m is. So m and 3 don't have a common factor. So my denominator is just m minus 3. And I could put that in parentheses. Finally, I cancel out anything that's the same on top and on bottom. So on the top and on the bottom, I have m minus 3 as one of my factors. So those cancel, and I'm just left with 2. Now, that is my solution. Okay. Now here I've got 4y squared plus 8y over y plus 2. Now notice 4y squared and 8y have a greatest common factor. So I'm going to need to factor that out first and then do my canceling. So I'm just going to take this part right here and factor it. 4y squared would be 2 times y. Then I've got a plus. 8y would be 2 times times y. What they have in common is my greatest common factor. So I've got 2 times y, or 4y. And then what I have left is y plus 2. So I factored out my numerator. My denominator, y and 2, they don't have any common factors. So I can just write y plus 2. And finally, I cancel out anything that's the same on top and on bottom. So I'm going to cancel out my y plus 2's, and I'm just left with 4y. Now I did make a mistake up here when I told you that this didn't have any excluded values because there's no variable in the denominator. When we find the excluded values, we look at the original problem, not the solution. So in this case, to find the excluded values, I would have to take 12h equal to 0. Okay, and then solve for h to find my excluded values. So if I divide both sides by 12, those cancel, and h equals 0 would be my excluded value. So that's part of my answer. Now in the second example, I have to take my original problem and set the denominator equal to 0. So m minus 3 cannot equal 0. And when I solve that equation by adding 3 to both sides, I get m equals 3 as my excluded value. So m cannot equal 3. And finally, in the last example, I need to take y plus 2 and figure out what could I sub in for y that would make that 0. So I'm going to set y plus 2 equal to 0, subtract my 2 from both sides, and get y equals negative 2 as my excluded value. Finally, we're getting to the real point of this lesson, which is simplifying expressions with integer exponents, simplifying expressions with like denominators. So here we have b over a to the third minus 2b over a to the third. Now, we don't know what b or a to the third means, but here's the beautiful thing about letters. They just stand for numbers. So, for example, if we had, say, 2 over 3, and we were subtracting 4 over 3, we have a common denominator here. So we can simply subtract the numerators and keep our common denominator. So 2 minus 4 would be negative 2. Now, the same holds true with letters because, again, they just stand for numbers. In this example, we have a common denominator. Our common denominator is a to the third. So in order to simplify this expression, we can subtract our numerators and keep our common denominator. So we can say this is the same as b minus 2b all over a cubed. So b minus 2b, those are like terms because they have the same bases to the same powers, the same variables to the same powers. 1b minus 2b gets us negative 1b, and we're still over a to the third power. And this is the simplified form of our expression. So all you have to do when you have like denominators, common denominators, is combine the numerators. b minus 2b is negative b. Now again, it's a rational expression, so we have to take the denominator in the original equation, a to the third, and set it equal to 0 to find our excluded values. Now to undo this third power, we would take the third root, and we have to do that to both sides. The cubed root of a to the third would be a, because the cubed root and the cubed cancel. And the cubed root of 0 is just 0. So a cannot equal 0. And in the second example, we have p q to the negative second minus 7 over p to the negative first q squared. Now, these don't look like they have common denominator, but before we make any assumptions, we want to simplify our negative exponents by moving them to the other side of the fraction bar. This q to the negative second is going to have to come down to become positive second, and this p to the negative first is going to have to come up. So that'll give us p, which stays on top because it has a positive exponent, over q squared to the positive 2 because we moved it to the bottom, minus the 7 stays on top because it has a positive exponent, and we move p to the negative first up to become p to the positive first, over q squared. That one stays on bottom because it already has a positive exponent. Now we can see that these two have a common denominator, the denominator q squared. So that means we can combine their numerators. P minus 7p all over q squared. And since p and 7p are like terms, we can combine them. 1p minus 7p would give us a negative 6p, and it's all over q squared. Now that's the simplified form. We have to take our denominator, q squared, and set it equal to 0 to find our excluded values. To undo a square, we take the square root. The square root of q squared is q. The square root of 0 is 0. So q cannot equal 0 is our excluded value. And our last example involves fencing a field. A rectangular field has a length 6a over 3a plus 4 kilometers and width 8 over 3a plus 4 kilometers. Find the amount of fencing needed to enclose all 4 sides. Now, the amount of fencing needed to enclose all 4 sides is just a fancy way of saying find the perimeter of this field. And we know that to find the perimeter, we simply add up all the sides. So I have 2 sides that are 6a over 3a plus 4. And I have 2 sides that are 8 over 3a plus 4. And when I add all those together, I can see that these all have a common denominator, which means I get to just add their numerators. So I've got 6a plus 6a plus 8 plus 8 all over our common denominator, 3a plus 4. When I combine like terms in the numerator, 6a plus 6a gets me 12a, 8 plus 8 gives me 16, and it's all over 3a plus 4. Now, once we've got this, we need to simplify it. So I'm going to do that thing I did before in the previous examples where I factor the numerator and then divide it by the denominator and cancel anything that's the same on top and on bottom. Now 3 and 4 don't have any common factors other than 1, and we don't know what a is. So we're not going to have a greatest common factor in the denominator. So let's work on the numerator. My factors of 12 are 2 times 2 times 3, and then I've got an a, plus my factors of 16 are 2 times 2 times 2 times 2. Right here, I have a 2 times 2 in common, so my greatest common factor is 4. And then what I'm left with is 3a plus 2 times 2, which is 4. So there's my numerator, and it's all over 3a plus 4. Here, my 3a plus 4 and my 3a plus 4 cancel, and I'm just left with 4. So the amount of fencing needed to enclose all 4 sides would be 4 kilometers.